Howdy folks, today we are going to be looking at Git and source control. This is a really important concept to know whether you're working on a personal project or if you're working on a larger team collaboration. Basically, anytime we're writing software, writing code, we want to be using source control. Let's get into it. So what is source control? It's also known as version control. That's another term. So source control, version control, they're kind of interchangeable. It's a way to ensure that all of your previous versions of what you're doing are backed up somewhere. Now, there's three reasons this is useful. One is it can be really useful to see how your code worked back in the past. Like maybe you made some massive changes and all of a sudden something doesn't work. And you need to go back and see, well, what did it look like before? It can also be useful to know who made a change. Maybe something is kind of complicated or you don't fully understand a feature and you really want to ask the person who wrote the feature why it works that way. You can go and look with version control and see who that person was. You can also with version control add comments into code and just not just like code comments, but add in on the particular change why that change was made, which can be helpful to give context on it. Google Drive, the history function of a Google document is a really good example of this for those of you that are familiar with that. So version control for code specifically is about specialized software that's meant to track changes in code. Git is the most popular program for this. There are others such as Subversion or Perforce, but they're not commonly used. Perforce is a paid product, and Subversion just there's people that really like Subversion, and I don't want to knock that, but Git, in my opinion at least, is just a lot easier to use, and so that's why I think it's a little bit more popular. So let's talk about Git, not GitHub. GitHub is a website that uses Git. GitHub is a remote server repository site. We'll talk about that in a second. Git is wider in scope than GitHub. Git is a program and a system that lives on your computer and helps you communicate with remote repositories. It was created by Linus Torvalds, the inventor of Linux, in a single weekend. He was fed up with existing software that had to do version control, said, I can do this better, and because he's Linus Torvalds, he did. The early version of Git that he created in a weekend was not as full-featured as what we have today, but a lot of the basics was there. Key terms of Git, we'll talk about each one of these in turn, but there's the Git server, the Git repository, branches, and commits. Servers. Git servers are servers that host repositories. They're meant to be external to your computer. You can run a Git server yourself, but the whole idea of Git is that you save your code somewhere else, similar to, for example, Google Drive. Again, you're saving your work somewhere else in case your computer crashes, you don't lose it. GitHub and GitLab are the most popular examples of Git servers, services that let you host repositories there and connect to them. You can run your own Git servers as well, and a lot of large companies will host their own servers too. Git does not require remote servers, but they're very useful. Repositories. You will have multiple Git repositories in your career. It's very common. They're not too expensive to create. Repositories are essentially just collections of files that make up projects. Git tracks all changes made to the repository, and it keeps all of those changes in a history. This is the main way we interact with Git is through repositories. So you download a repository, you'll upload to a repository. They're also commonly known as repos. That's just the short term. So if you hear someone talk about repos, they usually mean a code repository. Branches. Branches are structures in repository that allow you to track changes. Git starts with a main branch. There has to be at least one branch in the repository. Usually that's called main. On very old repositories, it could be called master as well, but most Git repositories now start with main. You can create other branches as well. The common use of branches is to track work that you want to save but aren't ready to publish. So you could create a branch for a feature you're working on, and then when you go home every day, you push your changes to that branch, that work is backed up. And then when you're ready to go, you push that branch into main. And we'll talk about how to do that in a later video. Branches are very cheap to create in Git. It doesn't cost really anything as far as memory or storage space to have them, so don't hesitate to create them. Commits is a specific set of change to one or more files. Commits are made on branches. So commits can include any change to a file, including creating new files or deleting files. Git keeps a list of all the commits to keep a history of what repositories look like at any point in the past. So one of the things about Git is it doesn't actually store your files. It stores a list of commits, and it actually uses those commits to kind of construct files, and that allows you to very easily move backwards and forwards in time. Let's take a look at what that's going to look like with an actual example. All right, so I have a directory I've already created. If you're pulling a remote repository, then often Git will create the directory for you. In this case, I'm not actually going to be doing a remote repository yet. We'll do that in another video, but I just want to show you how to push to a branch, because that's kind of the most important thing and the most common operation you're actually going to be doing. So we open up our terminal, and the main command we have in here is just git, G-I-T. And you can see it gives us a bunch of things that we can do. In this particular folder, I don't have anything yet. So you can see I don't have anything in this. So to start off, to make a new Git repository, we're going to run git space init, I-N-I-T. This is short for initialize, and it creates a brand new repository. Initialized empty Git repository. And VS Code actually, you can see, picks this up immediately and says, oh, you've got a Git repository. Nothing showed up here, but if I run ls-a, which is show everything, you can see now there's a new directory .git. And if I just look into that, there's a bunch of different files and folders. You're not usually going to be looking or dealing with this folder. Git takes care of that for you. It just needs to keep this data somewhere. So all of your commits are going to be in here, a bunch of info about the repository and stuff like that. So if you see a .git folder, it usually means that this is a repository, and it can be treated as a repository, and you can see VS Code again has picked that up. Now, let's create a new file. So you can see immediately this comes out with green with that U. That is something that VS Code is doing because it recognizes this is a repository. Now you can actually use, if you're using VS Code, the source control tab over here. You can commit your changes like that. However, I'm going to show you how to do it via the command line because that's, I think, it works even without the VS Code working. So the most important, or the first command you want to know here is git space status. All of these commands are, you type git space and then the command. This tells you your branch, whether or not you have any commits that haven't been pushed, any changes to files. So right now we have an untracked file. What that means is that we've created a file and we haven't told Git to track it yet. This is saying, hey, look, I know that this is a Git repository, but Git doesn't really pay much attention to this file, so keep that in mind. So what we want to do, if we want to save this file, okay, so you can see in VS Code, there's that little dot there. I have saved it, but it's not in the Git repository yet. Git has not saved it. And so there is an important difference there. Saving it means it's saved locally to my computer. Once you save it to Git, it generally means you've pushed it to a remote repository, so it's backed up. In this particular case, we're not using a remote repository, but the idea is the same. So the first, as it actually tells us, the first command we want to use for that, Git Add. Now, there's a couple things. If you put the dot, it basically adds everything in that directory. You could also use -a, Either one is completely fine. -A might be a little bit better because it'll catch all your files. Nothing happened, right? You can see this changed from U to A, which means it's been added. But what does that mean? Well, if I run git status again, you can see it no longer says that's an untracked file. It says changes to be committed. And if I look at here now, this is now a staged change. What is a staged change? Well, essentially at this point I've told Git, hey, here's a series of changes. Pay attention to these. Pay attention to these files. Whatever changes, I want you to gather all these together. So it's kind of like writing a letter. You've written the letter down at this point. But we're not done. The next step is to commit. Git commit. So now there's another thing you need to do here. You need to provide a commit message. What this is this is basically going to tell Git, here's the description of this particular change set. That's important because when you're looking back at this later, you're going to be able to read that and see, what did I do here? So in order to do this, you type -m. So that's git space commit space -m quote. And now type your message. So I'm going to say added beginning index file. Another quote. So you can see I have git commit -m quote my message end quote. If you don't type this -m and you run git commit, it's going to give you something that looks like this. Okay? Please enter the commit message for your change. Line starting with this will be ignored. Empty message aborts the commit. If you see the tildes here, you are in VI. This is the default editor for OS X or Macs. So what you want to do here in this case, if you get here, press I, okay, and type your same thing. Enter, or whoops, create new index file. Now press escape, :WQ. Okay? If you get to this point and you get confused, you can also just close the terminal. But this does kind of put you in a bit of a weird state. So it's better to handle the message. And what that did now is that created a commit. If you're on Windows using Git Bash, you may end up in Nano. In that case, you actually want to type your message and then use Control X to actually cause the window to close. You'll know it's Nano because it has a little thing at the bottom that gives you a bunch of little commands. It's VI if you see tildes on the side. Now that I made that commit, the other thing, if you use the -m, you won't end up in that case, which is why I kind of prefer the -m. Again, that's git commit space -m, your message, spell it right, like that. And if you do this, then you don't end up in that editor, which can make it a little bit easier. All right. Now, if I run git status, you can see on branch main, nothing to commit, working tree clean. Now, the final step. Now I've put that commit in. It's there. The final step is to run git push. Now, in my particular case, git push is not going to work because I don't actually have a remote. We'll go over how to handle a remote and how to add a remote later, but git push is what actually pushes your change to the remote server. It's kind of like mailing the letter. Committing it is like you envelope the letter. All right, so I've put the stamp on it, I've put the address on it, but it's still sitting in my house, which means if my house burns down, that's a terrible analogy, but it's kind of the equivalent of breaking your computer, then the letter still gets lost, right? I wrote the whole letter, I enveloped it, but it could still be lost. If I run git push, that's me putting it in the mailbox. At that point, it's safe. Anything happens to my computer, my change is going to be saved. So those three commands, git add -a, capital A, git commit -m with your message, and then git push. I recommend you do these often. I have seen a lot of people run into issues where they wrote a ton of code, and all of a sudden they said, wow, everything's broken now. If they had run Git commits frequently, they could go back in time to a previous commit when things did work. So that's one thing that Git is useful for. I've also seen people that have just lost their repository or forgot to push it entirely, and just their code is gone. So make use of your version control by Git Add, Git Commit, Git Push often. Usually what I like to do is whenever I've kind of gotten to a point where I'm ready to test something, then is a good time to do that. Anyway, I'll try to do a couple more videos on this because there's a lot of other topics on Git to cover, but that's it for this one. I hope it was helpful. I'll see y'all next time.